Okay, in this lesson today, we're going to look at the difference between association and causation. If you will set up your notebook, you've got association versus causation, and your essential question is explain the difference between association and causation. So by the end of this lesson, you should be able to answer that essential question. Okay, so I've got some definitions here for you. I'm not going to read this word for word because you are fully capable of doing that yourself. The first thing that I want you to notice is scatter plot. A scatter plot is just a graph of a set of data, so it's just a bunch of points. It would be similar to what we look at when we look at discrete data. We're just looking at individual points that are plotted on a graph. And when we look at scatter plots, we can identify them with different types of relationships. A graph can have a positive correlation or a positive association if the y is increasing as the x increases. I want you to see on this graph, this example of a positive correlation right here, that as our x values increase, notice our y values are also increasing. So as one thing goes up, the other thing goes up. This is also an example of what a graph of with a positive slope might look like. We also have negative correlations or negative relationships. And so basically this is saying that as our x values are increasing, our y values are actually going down. So it has the opposite effect. And then we have some scatter plots that have no correlation. There is no relationship. It's just a bunch of random points that really don't show any kind of pattern or trend. So a correlation is a relationship, is an association, is how things are relating to one another. If you look at the two examples, number one, in both of these graphs, it's important that we read our scales. We read what is being graphed on each scale. And I think that you could probably very easily say what kind of trends they are. Notice in the first graph, as our subscribers are going up, then our cellular service is going up. So that makes sense. We're going in an upward pattern. As one value is increasing, the other value is also increasing. So this would be a positive association or relationship. In the next example, notice our graph is aiming downward. So as our subscribers are going up, obviously the corded phone sales are going to go down. Nobody wants a landline. So this would be a negative correlation or association. So it should be really, really easy to identify if it's a positive or negative trend from a graph. Now, adding to that, we talked about, I've been interchanging the word association with correlation. So when things are associated or correlated, same thing. So association, associative. Association means there is a relationship. If we were to collect data and graph it, it would show that as one thing is increasing, the other is increasing. Or it would show as one increases, the other decreases. It would show a relationship. But the key thing here is that in an associative relationship, one does not necessarily cause the other. And the key word there is cause. For example, in the example here, if we were to graph shoe size compared to your SAT score, we might see a positive association because obviously the older you are, the bigger foot size you're going to have, and the older you are, the better you're going to do on the SAT than, say, like a kindergartner. So there would be a positive trend on a scatter plot, but by no means does your shoe size cause your SAT score, right? I would be like a genius if my shoe size caused my SAT score. So it doesn't, an association is there, but it doesn't cause it. Now, on the other side, though, we do have causal relationships. And the difference here is that a causal relationship does cause the change. And a key thing I want you to realize here is that you must have association with a causal relationship. And I want you to think about that. Why? Why do we have to have association, or why would there be association with a causal relationship? So when we talk about cause, it is actually causing it. So let's look at the examples below. We're going to determine if there's an association, and then if there is association, we're going to determine if there's a causal relationship, if one thing causes the other. I would suggest maybe to pause your video and see if you can answer these on your own first, and then turn it back on and see how you compare to what I said. It says, as the number of ice cream cone increases, the number of cars in the store increases. So they're telling us there's a relationship. As one thing is increasing, so is the other. So that is definitely a positive association. But let's ask ourselves, does ice cream sales, or does the number of cars in the parking lot cause us to sell more ice cream? And that would be absolutely not. Number of cars does not cause us to sell more ice cream. Sure, there would be, people there, but that is not the cause of selling it. Okay, the next one says, as the weight of a bowl increases, the total cost of yogurt increases. So again, as one thing's going up, so is the other. So yes, there is a positive association. And now let's ask ourselves, does this cause it? Does the weight of the bowl cause the price to increase? And absolutely, if you've ever been to Yummalicious, then you would know that yes, the more yogurt in your bowl is going to cause the price of it to go because you weigh it. So that would be an example of a causal relationship. Okay, the next one, the number of coffee shops in a city increases, the number of movie rental stores decreases. One thing is increasing, the other is decreasing. If we were to draw a scatter plot, we would see that this is a negative association. But does the number of coffee shops cause there to be less movie rental stores? No, not really. It doesn't cause us. Now, the coffee shops could be taking up more space, and we can look at factors about that. But it really has nothing to do with it. So there's no causal relationship. Okay, and then the last one is the cost of gasoline increases, the number of trucks sold decreases. So one thing's going up, the other thing is going down. So this would be a negative association. But does the cost of gasoline cause less trucks to be sold? No. It's going to maybe make people think twice about whether they want to buy a big car, but it's not actually causing the number of trucks sold to decrease. So the only one really here that shows a true causal connection is number 8.